Very good afternoon. Myself, Dr. Ruchi Gupta, Associate Professor, IT Department. In my previous lecture, I have discussed about the software testing basics, why there is a need of test cases, how many, what is test data, what is test suites. So, I have already discussed all these terms in my previous lecture. And we have already discussed software testing labels. So now these are the software testing level. One level, that is unit testing, I have already performed. I have already discussed in my previous lecture how we can perform unit testing. So unit testing is used to test the each and every, it is used for testing the modules individually, and basically it is a part of coding, and unit testing verify the coding. So once we have complete this unit testing, then we will move further to the integration testing part. So now today we will discuss integration testing in detail. So the purpose of unit testing is to determine that each independent module is to be correctly implemented and verified or tested by the unit testing approach. We have already done this unit testing approach. So this basically this gives little chances to determine that the interface between the module is also correct. So because with the help of unit testing, we have to test the modules individually. So there may be a chance of error in the interface among the modules. So with the help of integration testing, we have to just check the interface of the modules, and we have to integrate the modules, and finally we have to check the whole software. So this gives a little chance to determine that interface between modules is also correct, because there may be some error. Some error will remain in the module when we have to integrate these modules. So we check the interface also. So this is a part of integration testing, and for this reason we have to perform unit testing. And the focus of this integration testing is to check the interaction among the modules. So because the functionality is already checked in through unit testing, now we have to check the interface, or we have just focus on interaction of the modules in a subsystem. So unit testing modules combine to form a subsystem. We have to combine now all these modules and we'll check the system. So test cases to exercise the interaction among the different ways. So here we have to generate the test cases for checking the interaction. Now there are number of approaches of integration testing is available. So the first approach is top-down testing approach. So what we have to do in this top-down approach, so we have just start with the top level or the main module, and we have to integrate the software into the sub components. So we have to just start, and there is a need of generating the driver module in this case, because we have start from the main module. So we have to start with the main routine and two subroutines in the system. This is level 1. Then we have to check on the level 2. Then we have just gone to the level N, and there is a need of generating some stubs in this testing. At the time of top-down approach, there is a need of generating the these stubs, because we have to start with the main module. So there is no need of driver in this case, because we have just start the integration from the main module. So after top level skeleton has been tested immediately, now we have to integrate it with sub modules. So the subordinate of skeletons are combined and with tested. Now the top down approach, testing approach, it requires the use of program stubs that is used to simulate the effect of lower level routines that are called by routines under test. So we have generate, suppose I have to go on this level and we have to integrate this level 1 to level 2. Then there is a need of some requirement of some stuffs. So we have to generate these stuffs or to simulate the effect of lower level routines. That are basically, these are the called by routine under test. Now, when we have to start from the bottom level, so in the case of bottom level, there is no need of generating the stuffs, there is a need of driver, because we have to start with the lower level. In practice, most integration involve a combination of these strategies. Now, in the bottom up approach, we have to start with the subsystem and then we have to integrate all these sub modules and form a test the whole software. So, in this approach, in the bottom testing approach, each subsystem is tested separately. First of all, we have to test this module, this module, this module. Then we have to integrate in level 1, then level 2, and then we'll go for level n-1 to n level. So, a primary purpose of this testing is that each subsystem is to test the interface among the various modules making up the subsystem, and both control and data interface are tested in this bottom-up integration testing, and integrate the individual component in a level until the complete system is to be created. So, we have to test the software till the time until the whole software is to be tested. Now, once we have to complete this top-down and bottom-up approach of integration testing, then we will move further on the next level of testing, that is called system testing. So, means now we have done unit testing, means we have individually test the module, then with the help of integration testing we have to integrate all the modules and test the whole software. Now, once we have to test the whole software, now we will move further to the system testing. So, what is system testing? System testing, it is designed to validate a fully developed system. Now, we are ready to validate our final system, that to ensure that it meets all the requirements of the customer. So, these are essential 3 main kind of system testings are available. One is alpha testing, one is beta testing, and another one is a acceptance testing. As we have seen in this figure, that acceptance testing finally validate the user requirement. It finally validates the user requirement or user expectation. So, these are 3 types of testing comes under system testing. Alpha testing, it refers to the system testing that is carried out by the test team within the developing organization. So, alpha testing has been done once we have to test the whole software. Now, we have to test this software in the organizational environment, and if it is work correctly, then we will perform the beta testing. So, beta testing of this is the system testing that performed by a selected group of friendly users. So, beta testing has been done by the group of friendly users, those who are already use some software, similar software. So, such users have a knowledge about this type of software. So, they have performed beta testing. So, once we have to perform this beta testing also with the help of some friendly group of users, then finally we will perform the acceptance testing. And what is acceptance testing? Acceptance testing is a system testing that is to be performed to the customer. It is performed by the customer at the customer site only. So, because software is completely tested in the organizational environment. It is already tested by some group of friendly users. Now the software is ready for the deployment. So we have just checked the client or customer environment also, where we want to execute the software, where we want to deploy the software. So acceptance testing is the system testing that is to be performed by customer to determine that whether it should accept the delivery of the system or not. So means once this testing is done on the customer platform, then after the validation by the customer or after the acceptance by the customer, the software is to be deployed to the customer side. So we have done the acceptance testing for the for validate the customer expectation. Now these are some attributes of software that is to be tested during system testing. What we have tested during testing, system testing? So we have tested that it is usable, the product is usable, it is convenient, clear and predictable. We have to check that it is secure. It means it accesses some sensitive data that is restricted to those by the authorization. We also check the compatibility of the software with corresponding hardware. So will the work correctly in conjunction with some existing data, software and procedure? Now we have to check the dependability of the software. So we have checked that do adequate safeguard against failure and methods for recovery exist in the product or not. And finally, we have to check the documentation part, as the customer needs some user manuals for using the software. So are the manuals are complete, correct and understandable. So we have to check all these things in the system testing phase. So once we have to complete all the levels of testing, now we will discuss that what type of strategies, what type of software design strategies are available for checking the software. So basically there are two type of designing strategies are available, which we have discussed now. One is a black box testing approach and another one is a white box testing approach. So black box testing is also called functional testing, or it is a behavioral testing or black box testing. So why it is called black box? Because user is unaware about the structure or the code of the project. User is not aware about the structure of the code. So we have just test the software on the basis of input and output of the system. That's why it is called black box testing. So in the black box testing approach, we have to generate some test cases that are designed usually only for the functional specification of the software. It means without any knowledge of the internal structure of the software, we have just checked the software on the basis of input and output. In the black box testing, the tester only knows the input value that can give into the system and what the output which we have received by the system. And it involves only the observation of the output for the certain input value. We have just observed the output on the basis of certain input value, and there is no attempt to analyze the code which produce the output. Means, as I have already told you that we are not bothered about the code. We are not aware the code. We have just checked the software on the basis of input and output value. So an approach of testing where the program is considered as a black box because internal structure of the code is to be ignored here. That's why it is called black box. Now, in the black box testing, we have to design some test cases for examination of the input output values only, and no knowledge of design and coding is required for functional testing or for performing the black box testing. So, black box testing, we have just put the input into the system. This is system under test, and finally it will give some output. There will be an input domain and there will be some output domain. So, input causes anomalies in the behavior of the system on the basis of input. This is our system, and this one is output, which reveals the presence of defect in the system. So, means we can say, if we are not receiving the output, if the expected output is not same as the actual output, it means we can say that there is some error in the program or project. There are certain types of black box testings are available. One is a boundary value analysis. Next is an equivalence class testing partitioning method. And third one is a cause effect graphing method. So, the first method which we have performed, that is boundary value analysis. So, what is boundary value analysis process? So, basically when we have to test our software, so there will be more chances of error at the boundary of the input domain, input or output. Means, for example, programmer may use some improper keywords, greater than instead of greater than equal to, or converse greater than equal to for greater than. It means when we have to put some output, then there will be more chance of error in these boundaries, less than or less than equal to. So, boundary value basically check the software on the boundaries only. So, test cases that are close to the boundary value conditions have a higher chance of error. So, we have with the help of this boundary value analysis, we have to check the software on the boundaries. So, boundary conditions means how many boundary conditions are? Input value may be the boundary. So, we have just checked 5 values. Boundary value means minimum, just beyond boundary means just minimum, one middle value, then just above boundary, just maximum, or boundary value, maximum boundary value, that is maximum value. Because programmers fail to see the spatial processing required by the input values that lied on the boundary. So, for example, there is some input domain A and B, C, D. So, these results will come under this boundary. So, for example, x is greater than equal to b and it is less than equal to b, and y is greater than equal to c and less than equal to c. So, these are the boundary, less than equal to and greater than equal to. We have just checked these boundary, that it will give some correct result or not. So, we have just take one example. First of all, we have to generate some test cases for the boundary value analysis. So, for any program, if we have n input variables, then boundary value analysis, it yields 4n plus 1 test cases. Suppose if we have 2 variables, then we have to generate 9 test cases, and we have to put 5, we have to check 5 boundary values: minimum, just minimum, nominal value, just below, or maximum. So, we will take one example. Consider a program for the determination of nature of roots of the quadratic equation. It is a triple of positive integers a, b, c. It means we have 3 variables here. So, we have generate 4 into 3 plus 1, 4 into 3 plus 1, because the formula is 4n plus 1, means total 13 test cases we have to generate for this program, and the input domain range is 0 to 100. So, the equation is ax square plus bx plus c is equal to 0, and we have to check all these, that roots are real, imaginary, or equal, or not quadratic. So, here we have to generate 13 test cases, and we will take put the each and every variable on the boundary. So first of all, we have to put A on the boundary, then B, then C. So 0, 1, 50, 99 or 100. These are the boundaries of A. Now put B on the boundary, 0, 1, 99, 100. Then put C on the boundaries. So now we have put all these test cases. We have generated these 13 test cases and put the value, put the input value, and we get some output on these 13 test cases. So here, if it gives output as per our expectation, so means we can say the software is correct on the boundaries. This is another example of boundary value analysis. These are some examples. Now we come on the second method, that is equivalence class partitioning. So we have already checked the software on the boundaries. Now we have also checked the software beyond the boundaries, because beyond the boundaries we also get some results, but these we have to divide the whole output into two classes. One is a valid class and another one is invalid class. So the results which come under within the boundary, they will come in the valid class, and the results which come beyond the boundary, they will go on to the invalid class. So that this is a equivalence class partitioning approach of testing. So in this approach, domain of input values to a program, it is partitioned into the finite number of equivalence classes. The partition is done such that the behavior of the program is similar for every input. And the main idea for defining the equivalence class is the testing of the code with any value that is belonging to equivalence class is as good as testing the software with any other value belonging to that equivalence class. So basically, equivalence class, it can be designed for the examination of input and output data. So we have just divided the whole class into two classes. If inputs specify the range, if it is come within the range, then the results will go into valid class, and invalid classes are also defined. So for example, if input condition is Boolean, one valid, one invalid class. Now, two steps for performing this equivalence class testing. For example, the equivalence class are identified taking each input condition and partition into valid and invalid class, as I have already told you. Now, if input condition specify the range of the value from 1 to 999, means the input which we have to given between 1 to 999, these results will go on to the valid class. And if we have to put any input that is greater than 999 or less than, if item is less than 1, then these results will go into the invalid class. So we have just take the similar example here of the quadratic equation. So we have put here some conditions, like because the input domain range is 1 to 100, then one condition is A is less than 0, A is equal to 0, and A is greater than 100. Similarly, we have put V greater than 0, less than 0, V greater than 0, and between 0 to 100. So we have to again generate test cases and perform this testing. So thank you very much.